Hi everyone, we're going to do HSC New South Wales Advanced Mathematics past paper 2019. This is a walkthrough video. So we're going to start doing the longer response questions. So question 11. Part A is using the sine rule, find the value of x correct to one decimal place. And it's got this diagram. So all we have to do is find x. So we can repeat the sine rule, which is on your formula sheet, which is A on sine A equals B on sine B equals C on sine C. Okay, this means the sides, and the angles. So if we were to draw a triangle, this is angle A, this is side A, this is angle B, this is side B, this is angle C, this is side C. Alrighty, so going back to this question, if we have this angle, it's this side, so it's 8 as A on sine of 110 equals B, which is x, B, on sine 40. Alrighty, so we can rearrange this. So x equals 8 times sine of 40 divided by sine of 110. And we grab our calculator. Oh, what the heck? Anyway, well, that didn't go well. So x is 5.47. And it says to one decimal place. So we need only one number here. So it's x equals 5.5. Alrighty, part B. Differentiate x squared sine x. So we've got this rule that, so first we let y equal x squared sine x, and we've got this and this as two separate parts. So we've got the x squared and then we've got the sine x. So we're going to do the chain rule, I think it is. So y dash is grab this guy and just write him there, and then differentiate sine x, which is cos x, plus grab this guy, sine x, differentiate this guy, 2x. So all you got to do is grab the first guy, differentiate the second guy, plus grab the second guy, differentiate the first guy. That's how I think of it. Or you've got this formula on your sheet, and it says if y equals uv, dy by dx is u dv dx plus v du dx. So this is the same thing. So the differentiation of y is u, which is x squared, times the differentiation, so this is u, this is v, differentiation of v is cos, differentiation, of sine x is cos x, plus v sine x, and the differentiation of u, which is x squared, which is 2x. So we know we've got it right. You could either use this formula, or you can just go grab the first guy, hit the second guy, grab the second guy, hit the first guy. That's how I think of it. That's how I was taught. Alright, question C, differentiate 2x plus 1 on x plus 5. So I like using the formula given in the formula sheet here. So we've got dy dx equals v du on dx minus u dv on dx divided by v squared. So first so that's our formula. Let's put it in a box. So first let y equals 2x plus 1 divided by x plus 5. So we just grab the question and let y equals. So label what are we labeling? We're labeling u and v. So the top thing is u and the bottom is v. So if we've got dy dx, we just use the formula. V, which is the bottom, we put that there, x plus 5. So we've done this. Now we're going to do this. Du dx. So grab the top, 2x plus 1. What's the differentiation of 2x plus 1? It's just 2. So we just put a 2. The minus, what's u? U is the top, 2x plus 1. dv on dx, so is the differentiation of the bottom. So the differentiation of the bottom is just 1 divided by v squared, so it's the bottom squared. So dy on dx is 2x plus 5 minus 2x plus 1 in brackets, keep the brackets there, divided by x plus 5 squared. So dy, we can simplify this even further. Move this up a bit. So it's dy dx equals 2x plus 10. All I did was expand these brackets like that. Minus 2x minus 1 divided by x plus 5 squared. So you can simplify this, so 2x minus 2x, they're crossed out, 10 minus 1 is 9, so it's dy on dx equals 9 on x plus 5 squared. But in an exam situation, I think that this would be fine, so you could actually just stop there and simplify. But if the question said differentiate and simplify, you would have to go to this point. Alright, let's get rid of that. Let's do d. What does d say? Okay, d. What is the limiting sum of the following geometric series? So, key words here. Limiting sum and geometric series. So as soon as I hear that, I would go to my reference sheet and look at the equations that are similar, that relate to the geometric series and the limiting sum. So we've got this series, 2000 minus 1200 plus 720 plus minus 432 ... Okay, so we know a is the first number in the equation. So we know the limiting sum. First, we use this equation. S infinity is a on 1 minus r, because we know the limiting sum means n is going to infinity. So as n gets very large, if we go to n equals 800, we're all the way over here and get the 800th value. So the limiting sum is, what is the value of the sum when n is infinity? That's pretty much what it is. So a is the first number in the series. So a is 2000. R is the difference. So r is actually the second number divided by the first number. So 1200 divided by 2000. So r is negative 0.6. So now all we have to do is sub this into the equation. S infinity equals 2000 divided by 1 minus negative 0.6. Remember, there's a negative here, but r itself is also negative, so this will turn into a positive. So S infinity is 2000 divided by 1 plus 0.6, which is 1250. Alrighty, that was B. Let's do E now. E, evaluate. evaluate integration of 1 to 0, 1 on 3x plus 2 squared dx. Okay. First thing to notice is this 1, we can get rid of the fraction to start. So we've got integration of 1 to 0 of 3x plus 2 to the negative 2 dx. So if it's a fraction with the 1 on the top, all it's doing is adding a negative to the power. This is the equivalent. So 1 on x, this is separate to this question, I'm just explaining the concept here. 1 on x is the same as x to the minus 1. Or 1 on x squared is the same as x to the minus 2. So what we're doing here is the same thing, but now we've just got the 3 and the 2 in there as well. Alrighty, so what we need to do is we need to integrate this guy. So what it is it's integration of 1 to 0 of, we go to our formula sheet first, I should have said that. So we go to our formula sheet, and we know that, I'll write the formula. So pause for a second, write the formula. Integration of ax plus b to the n dx is ax plus b to the n plus 1 divided by a n plus 1 plus c. So what do you think this is? So I'll flip this over so we can start, and I'll write the formula up here. Okay, so since we've got values, what was it, 0 and 1, we don't need the c anymore. We put square brackets and we go to 1 from 0. That's what we do. So if we have, what have we got? We've got integration of 0 to 1 of 3x plus 2 to the negative 2 dx. So let's just literally just use this equation. So first write square brackets. What have we got? Ax plus b. So ax plus b. So just write the same thing. 3x plus 2. Now what's the power change to? It's gone from n to n plus 1. So what do we need to do to this? We need to add one value. So it's negative 2 plus 1, which is negative 1. Divided by a. A is the number in front of the x. In this case it's 3. Divided by n plus 1. So before it was negative 2, adding 1 to it, so now it's negative 1. There we go, from 1 to 0. So this is the same as 3x plus 2 to the negative 1 divided by negative 3 from 1 to 0. So what we can do is we can pull this 3 out, because since it's got no x values down here, we don't need to keep it within this values. So it's 1 on negative 3 times 3x plus 2 to the negative 1, 1 to 0, which is 1 on negative 3, 1 on 3x plus 2. From 1 to 0. So what's happened here is this negative has actually turned back into the fraction. Remember when I said 1 on x is the same as x to the negative 1? We're going back this way. So if it's if it's 3x plus 2 to the negative 1, it's 1 on 3x plus 2. That's what's happened here. So 1 on negative 3, square brackets, 1 on 3, put a 1 in here, 1 in first, plus 2, minus 1 on 3, 0, plus 2. So it's sub in the first number minus sub in the second number, with the 1 on negative 3 out the front. So this simplifies to 1 on negative 3, 1 on 5, minus a half. So this 3 is gone, because it's times by 0. So it's just minus half, which is 1 on -3, -3 on 10, which is 1 on 10. So sometimes, say I was all the way up here, right? Instead of simplifying it where I can possibly make a mistake, a good thing to do probably in an exam would be to just substitute. So it'd be 3, if I can get my calculator. Why aren't you working? Okay, there we go. So say we were here, all I would do would be 3 times 1 plus 2 to the power of -1, -1 divided by -3 minus. So I subbed 1 in, that's all I've done. So I'm up here and I'm substituting into my calculator. Just saves making a mistake like that. So it's 3, 0, because I'm subbing in 0 now, plus 2 to the power of -1 divided by -3. 1 on 10, which is the same answer we got if we simplified it. So we've saved 1, 2, 3, 4, 5 lines of math and probably the same amount of time to do it all. So, you know, I would just stop here. I know it's not in the simplest form and just get the answer. There we go. So what question was that? That was... what was that? E. So we've got F. Is that it? Sorry, I'm just looking at the exam on my laptop. No, I've got F and G to go. Alrighty, I need more paper. Alrighty, F. A bag contains 5 green beads and 7 purple beads. So I'm studying mathematics and statistics in university, and I'm in my 2nd year, and I hate probability for the life of me. So don't judge statistics on probability. So 2 beads are selected at random without replacement. What is the probability that 2 beads are the same colour? So first, we're like, okay, there's 5 green, 7 purple. How many beads are there total? So total beads is 5 plus 7, which is 12. So if I have a bag, so say I have a bag and I've done nothing to it, what proportion of beads are green? There's 5 beads that are green out of a total of 12 beads is green, and 7 out of 12 beads are purple. That's something to note. That's a good thing to note. So, what are the probability that the 2 beads are the same colour? So, 2 beads of the same colour are both green or both purple. It's not an and because they can't both be green and both be purple. So say I was only drawing out twice. They can't both be green and both be purple simultaneously. So it's an or question. So the 2 beads are the same colour when they are green or when both are purple. So the probability of both being green. So at the start, nothing's happened. What's the probability of drawing a green ball? Is 5 out of 12. Okay, times. What's the probability that the second ball is green? So there's 1 less ball in the total bag. But we did take out a green ball to start. So there's 1 less green ball as well. So it's 4 out of 11. So what's the probability of both purple then? There's 7 out of 12 purple beads to start, times, now there's 11 beads, there's one less purple one because that's what we drew it out. So it's 6. So the probability of the same color is probability of both green plus, let's bracket, probability of both purple. So it's 5 out of 12 times 4 out of 11 plus 7 out of 12 times 6 out of 11, which is 31 on 66. Brilliant. G. Points. Sketch. Okay. Sketching. X and Y axis. Please use a ruler, you will get marked down, so don't do what I just did. Parabola. This guy. Also recommend you getting a thing called a Mathomat. I've got 3 of them. You're allowed to take them into your HSC exam, or when I did the HSC you're allowed to, which was back in 2018. So it's got graphing, it's got functions, it's got the sine wave, cos wave, parabola, cubic. It's just great. It's just really helps with the graphing. It's a ruler as well. It just helps you graph anything if you really struggle with freehand like this monstrosity. So I really recommend getting one of those. They're about $20 for a piece of plastic, which is ridiculous, but still, it's worth it. Alright, so this is y equals x squared, and y equals x plus 2. So this is the y-intercept. So where it hits a y-axis. So it hits a y-axis at 2. So we just draw that line like that. So y is greater than or equal to x squared and y is greater than or equal to x plus 2. So this one's easy. Grab it and just push it above, so it's anything above here. And now we've got to figure out whether it's in here or it's out there. So if it's greater than x squared, it'd be in here, be within the x squared. And it's just as easy as that. Thanks for watching.